Chapter 1.7.3 Secrets. The text discusses the importance of using secrets in Kubernetes, which are objects that store sensitive data such as passwords, tokens, and keys. By using secrets, confidential data can be kept separate from application code, reducing the risk of exposure during the workflow of creating, viewing, and editing pods. However, it is important to note that Kubernetes secrets are stored unencrypted by default, making them vulnerable to unauthorized access. To enhance security, it is recommended to enable encryption at rest for secrets, configure RBAC rules for least privilege access, restrict secret access to specific containers, and consider using external secret store providers. Following good practices for managing secrets and implementing information security measures can help improve the overall security of your Kubernetes environment. It is crucial to take necessary steps to protect sensitive data stored in secrets and prevent unauthorized access. Uses for secrets. Secrets in Kubernetes are used for various purposes, such as setting environment variables for containers, providing credentials like SSH keys or passwords to pods, and allowing the kubelet to pull container images from private registries. The Kubernetes control plane also utilizes secrets for tasks like automating node registration using Bootstrap token secrets. One use case is hiding data by defining a key that begins with a dot, making it a dot file or hidden file. These dot files can be mounted into volumes, making them visible in the container at a specific path. Another use case for secrets is making them visible to only one container in a pod. For example, separating a complex application logic into two containers, one for handling user interaction and business logic, and another for signing messages with an HMAC. This partitioned approach ensures the private key is not exposed to the front-end container, enhancing security. Instead of using secrets, alternatives like service accounts, third-party tools, custom signers for X509 certificates, device plugins for encryption hardware, and operators for managing session tokens can be considered for securing confidential data and authentication. These alternatives can be used individually or combined based on the specific security requirements of the application. This allows for a flexible and customizable approach to securing sensitive data in Kubernetes environments. Types of secret. Secrets in Kubernetes are used to store sensitive information such as credentials, tokens, or keys. When creating a secret, you can specify its type, which determines how the data is handled. Kubernetes provides several built-in types for common scenarios, such as opaque, service account token, Docker config, basic authentication, SSH authentication, TLS, and Bootstrap token secrets. Each type has specific requirements and constraints that must be met. Opaque secrets. Opaque is the default secret type, used when no type is specified. It is ideal for storing arbitrary data. When creating an opaque secret, you can use the generic subcommand in kubectl. Opaque secrets do not have any specific constraints and can store any type of data. Service account token. Secrets. This type of secret is used to store long-lived credentials for service accounts. In newer versions of Kubernetes, it is recommended to use short-lived tokens obtained through the Token Request API instead. Service account token secrets should only be created if the Token Request API is not an option, as they expose non-expiring tokens. Docker config secrets, used to store credentials for accessing a container image registry. Docker config secrets support two types, Docker CFG and Docker config JSON. These secrets must be created with the appropriate type and contain the necessary data in a base 64 encoded format. Basic authentication secrets. Basic auth secrets store credentials required for basic authentication. They must contain a username and password or token encoded in base 64. While an opaque type can also be used for basic authentication, using the defined kubernetes.io/basic auth type helps maintain consistency. SSH authentication, secrets. SSH auth secrets store data for SSH authentication, requiring a SSH private key pair in the data field. Similar to other types, using the defined kubernetes.io/sage auth type ensures consistency and clarity in the use of secrets. TLS secrets. TLS secrets store certificates and private keys used for TLS encryption. These secrets must contain keys TLS-TRT in the data field, and while an opaque type can be used, using the defined kubernetes.io/TLS type is recommended for consistency. Bootstrap token secrets. Bootstrap token. Secret store tokens used during the node bootstrap process, typically in the kube system namespace. These secrets contain a token ID, token secret, description, expiration, and usage flags. Creating a bootstrap token secret helps in securely handling tokens during the bootstrap process. Overall, understanding the different types of secrets in Kubernetes and their specific requirements is essential for ensuring the secure storage and handling of sensitive information within your cluster. Working with secrets. Creating a secret in Kubernetes can be done in several ways, such as using kubectl, a configuration file, or the Customize tool. When creating a secret, it is important to note that the name of the object must be a valid DNS subdomain name. The configuration file for a secret can include the data and/or string data fields, with values in the data field needing to be base 64 encoded strings. Alternatively, the string data field accepts arbitrary strings as values. Keys for both data and string data must consist of alphanumeric characters, MSCOR OR. In case of conflicts, the value specified in the string data field takes precedence. Secrets have a size limit of 1 MB to prevent exhaust of API server and kubelet memory. Editing a secret can be done using kubectl, a configuration file, or the Customize tool. Updates to existing secrets are automatically propagated to pods that use the data. Secrets can be used in pods as data volumes or exposed as environment variables. They can also be utilized by other parts of the system without direct exposure to pods, such as holding credentials for interacting with external systems. Optional secrets can be marked as optional, allowing Kubernetes to ignore them if they do not exist. By default, non-optional secrets are required for a pod to start. Secrets can also be accessed as files within the file system of a pod's containers, with Kubernetes tracking updates to ensure consistency. Using secrets as environment variables involves adding environment variables for each secret key in the env value from.secretKeyRef field of a pod specification. Container image pull. Secrets can be configured to authenticate the kubelet to a private repository when pulling images. Image pull secrets are used for this purpose, passing a secret containing the registry password to the kubelet. These secrets can be manually specified or attached automatically to pods created with a specific service account. However, it is important to note that config maps or secrets cannot be used with static pods. Immutable secrets. Kubernetes v1.21 introduces a new feature where secrets and config maps can be marked as immutable, preventing changes to the data of existing secrets. This provides protection against accidental updates that could cause application outages and improves cluster performance by reducing load on Kube API server. Immutable secrets can be created by setting the immutable field to true, and existing mutable secrets can also be updated to be immutable. Once a secret is marked as immutable, the change cannot be reverted, and the data field cannot be mutated. Existing pods with a mount point to the deleted secret should be recreated. Information security for secrets. Config map and secret in Kubernetes are similar. But secrets have additional protections since they often hold sensitive information like service account tokens. This data can cause issues if accessed by unauthorized apps. Secrets are only sent to a node if a pod on that node requires it, and they are stored in a TMPFS by the kubelet to avoid writing them to durable storage. Each pod can only access the secrets it requests, and containers require explicit definition of environment variables or volumes to access any other secret. To further enhance security, Kubernetes allows for the annotation of service accounts to enforce least privilege access to secrets. It's important to note that containers running with privileged access on a node can access all secrets used on that node. It is essential to configure secure access to secrets to prevent unauthorized access and maintain data security.